Hello, my name is Telesfor Billy from NTU, Quantity Surveying Master Program in NTU. This is just to present Birmingham City Library as part of my chosen building for the coursework, part 1. The new Birmingham Central Library started, in other words, the design started in 2008 by an architect called Francine Huben from Meccano architecture firm. The building is magnificent, and it was handed over to Birmingham City Council in 2013. The library stands at the moment as the largest of its kind in Europe. It's quite attractive in terms of features. Externally, it's quite attractive, and inside is very quiet despite the movement of people, escalators, and that feature is quite amazing. The building work was undertaken by Carillion, the main contractor Carillion, which commenced the work in January 2010 and handed over in 2013. Effort to get a detailed design was not successful. But on this report, I will focus on the foundation. That is how the foundation was built, the floors, what are the methods that were used to build the floors for each level, the columns, pile, interior, sustainability, etc. Now, this is the front elevation with quite so many people in front. That signifies that the social infrastructure as it is quite successful in attracting people from all backgrounds for different purposes. And that is a goal that was set by the council, which obviously has been reached successfully. The golden dome that you can see on top is also visible from different parts of this Birmingham city. Now, if you notice at the bottom of the ground floor is mainly covered with glass all around, and that is a method also to harvest daylight and therefore reducing lighting consumption within the premises. We can also go far by mentioning greenhouse heat retention. That is during the winter when there's a sunlight. Obviously, the greenhouse theory, that there will be heat transfer to the glass, which obviously will mitigate the excessive use of heating at that time with the import heating through the glasses. By then, this will help reduce energy bill. There are few facts that is worth mentioning. There are 3 levels of facts that I will mention along this presentation. This is the first set of facts. The library covers an area of 35,000 square meters. That includes all the floors, and there are 9 floors in total. Estimated budget to construct the building initially was set to be 190 million, but the finished cost was 189 million, which is 4 million saving. And this is excellent planning by Carillion to be able to achieve such saving. The library contains 100 million books. There are over 800,000 membership across the city and obviously Greater Birmingham. Among the 10 most visited places in the UK, Birmingham City Library has been counted to be, I think, number 10, which is with 2.4 million visitors per annum. This is a section view of what the library look like, and we can all see that the basement is quite large with a lot of facilities inside and different floors, and see the pattern of the stairs and so on. Talking about the foundation now. Now the foundation, according to the document that we gathered, the foundation started with excavating the original floor, the ground, to the desired depth of the foundation level. So the method was to remove the material from the ground and then compact the ground after the desired level is achieved. And then there are two methods that was used. The final document for the foundation was not obtained, and therefore there are two methods here. The first one is to obviously put some piling underneath the concrete bed to solidify the concrete bed, or the next one is in the middle, that's right in the middle, is to let the building rest on the concrete bed and put some piles all around the basement wall, all around the retaining wall, I would say the retaining wall. And this is only done if the ground is stable and quite strong. That might be the solution. But it's done, I'm sure that the method used here should have some piles to support the whole structure. There are two methods commonly used, and for the piling, is displacement and replacement piling. I will elaborate further in the other slide. And this is the displacement pile. The displacement pile document is obtained from lecture note of the 21st of February 2018, and that was lectured by Clive Wright. And so the first method is displacement piling. It displaces the ground, and by using those machines that you can see on the picture, drop hammer, to push the concrete, the prefabricated concrete, precast concrete, into the ground. With this, the piling dimension varies from 200 to 350 millimeters square, which is quite small, it's not that big. And this method is also something that could have been used, but as it stands, the structure of the Central Library is quite massive, and this method may not be the one that was used. Replacement pile or replacement piling, and that is what the method that they've used, because the column in the building obviously are quite, some of them, especially the ground floor, are quite voluminous. So this is a method that was used. Now, using a borehole machine with a powerful rotary bore, the ground is removed and replaced with concrete. Now, some of these machines have a concrete in situ concrete injection system, whereby while digging or creating a hole, the injector will inject the concrete directly into the ground, the hole that is being made when the rotary board is being removed gradually. And that is a very quick method to do it, and it's also, it might be a bit expensive but cheaper overall, and it's suitable for large diameters like a structure like the Central Library. And these are the basement wall, and they are formwork that are used all around the retaining ground. The ground to form the retaining walls. And this is what is used. There are also formwork. So formwork is not just for columns. There's also formwork for walls, basement walls. And that's an example of what happen when piles are when retaining walls have been built and piles are also been erected. Normally, the piles in the case of the Central Library will not be these ones, because these ones are the size similar to a displacement piling method. But the replacement piling, the piling are much bigger, and they will normally sit similar as this one. They will sit on pile caps that has been gone in the ground with the part that comes outside the pile caps, and the new pile will sit on it until the concrete is cured to form a solid structure. And this is an example of what the column, the basement column would look like, especially the one on the right. But the method to use, there's a metal formwork and the cardboard formwork. Both could have been used depending on the project. Now, these are placed on the pile cap and pour the concrete inside until the concrete is cured to remove and use it for other column as like the reinforcement metal are waiting on the front in the right photo on front. That is the next one would have been a metal reinforcement, concrete reinforcement metal, to bring it around it and pour the concrete inside. Now, according to Bureau Happold, that company was a structural engineer for the project. What they've said in their document is the method that was used for the floors was a post-tension concrete structure. Now, the post-tension concrete structure is made of tunnels. There are small tunnels in the concrete where wires are driven into on both sides of a structure, and they are pulled together to create a tension. And the concrete is poured. In this way, the concrete is able to support more weight and is also light and thinner than normal in situ concrete. This is an example of what they look like. On each side, we can see the metal wires on each side. These are the metal wires that are pulled together to create the post-tension concrete floors. That's what it looks like. If you can look at the floor from the floors from the bottom of the floor, we can see that everything is quite uniform, supported by the pillars on each floor. That's what the building looked like before it was finished. And there's openings also all around the building. This is concrete shaping to help harvest daylight, and this is purely outside of a building. That is part of a basement, but it's outside. And we can also see the columns all around the shaping, the concrete shape form. There are columns all around. This is an example of what they've used, the system used, the technique. There is obviously a rounded shape of a column of a concrete all around, and that is done to give an opening that will help harvest more daylight. The most dominant material for the structure is obviously concrete. Now, these are a few engineering facts that was gathered. Building is designed to host 10,000 people a day. Exterior metallic rings are 5.4 meter in diameter for the black rings, and 1.8 meter in diameter for the silver cycles. In total, there are 5,357 circles. The amount of concrete used to construct the library is estimated to be 21,000 cubic meters. Steel frame was also used internally to reinforce the concrete, and that is 3 tons altogether. Amount of excavated material, that's the ground, the soil that was removed, 30,000 cubic meters. Now, the highest point of a building, that's the height of a building, 60 meters, and the lowest point is 6, that's a basement, 6 meters deep. Now, that's the example of a steel frame structure that was used to support the concrete inside. Is evenly mounted all across the cycle. And this is a finished picture of a building, how glamorous and beautiful it looks like. The building was completely able to meld together with the rep and the symphony hall in Birmingham area. So it makes the place very beautiful as a structure. And that's a picture of the interior, what it looks like. You can see from the bottom of the picture on the floor where the two gentlemen are standing, there is a lot of daylight coming. There's a flood of daylight coming to the building, and that is one of the purpose, obviously, of sustainability, to allow daylight, to use more daylight and reduce internal energy usage such as lighting. So they successfully managed to harvest very good amount of daylight. Again, this is a good example of another floor of how daylight has been successfully harvested, and that work in reducing energy cost within the building. In terms of sustainability, the building has achieved Birmingham excellent with 74% grade. Natural ventilation also is available throughout the openings. Obviously, it's covered. To protect against rainfall, but there are other openings that bring in some natural ventilation. High efficiency facade all around behind the rings or the metallic circles stand also as insulation. Rainwater harvesting is available. There's a system available for harvesting rainwater, and the water is reused for flushing toilets, which is part of sustainability and energy saving. There is also on-site grey water recycling system. That is every water that is used at every level, from kitchens, sinks, dishwashers or machines. These are the grey waters. They are also recycled. Sustainable building material. Most material were used on purpose to meet energy saving requirements, whether the insulation materials and low emitting materials for finishings and so on. Ground source heat pump is also used for heating. And ground source heat pump is a system that harnesses heat from the ground, combining with the output of a pump to be able to generate more heat. In other words, with less effort, the pump is able to generate the heat desired for the building. And that can bring a saving up to from 30% to 40% in some cases if the property well insulated. And so ground source heat pump is a very good solution here for the heating of such a volumetric building. Daylight is maximized. We've spoken about it on the earlier slide. Is also maximized to reduce energy cost. In conclusion, the new Central Library remains obviously a great achievement in meeting with the public and environmental needs, which is the desire for the client, Birmingham City Council. The designers, architects, obviously contractors, they're all working together as a team, successfully achieve a good result in saving energy, which is environmental conscious. I was privileged to see the beginning, because when I used to work with Carillion, the TPS company that followed up the design were bought over in vertical integration by Carillion, so they came to our office. We shared office together, so there was a lot of question, a lot of excitement during the project. The team was excited. We were all excited, asking questions. In terms of structural solutions of concrete, the mixture of concrete and steel frame here has probably contributed to reduce the cost of the overall structure, and therefore saving 4 million. This is also commendable as a method or solution. Thank you for listening. This is again Telesfor Bile, MCS Quantity Surveying, Nottingham Trent University. Thank you.